On a dark, moonless night, a misty light reaches up across the sparkling vault of the heavens. At first, it looks like a cloud or a puff of smoke that could blow away on a stiff breeze, but it holds to its place among the stars. Because this is something more permanent and more intriguing than a passing cloud. This is what the Romans once called the Via Lactea, the Milky Way. And for astronomers through the ages, it has proved to be a pathway to discovery. To ancient skywatchers, the Milky Way was a mystery that became a myth. Some saw it as the wake of a celestial ship, others as the seam where the two halves of the sky were stitched together. But these stories and legends say more about the people who told them than they do about the true nature of the Milky Way. To the ancient Greeks, the Milky Way was formed when the goddess Hera awoke to find a strange infant, the baby Hercules, suckling at her breast. The divine milk bestowed immortality, but when Hera realized she'd been tricked, she pushed the babe away, and the spurting milk sprayed across the sky. Today, our word galaxy comes from the Greek word for milk. But stories aside, the Milky Way's true nature was hidden until people could see it through a telescope. It was 1609 when Galileo first turned the new invention toward the Milky Way's misty light and recorded what he saw. Galileo had discovered that the Milky Way is made up of countless stars, stars that are too far and too faint to see individually. Yet together, they paint the sky with a luminous glow. It was a realization that changed everything because it gave depth to the night sky. And it meant astronomers were free to explore a heavenly realm that the ancients had never dreamed of. Galileo noticed that the stars in the Milky Way are sometimes grouped in clusters. And as telescopes improved, astronomers discovered something else. Clouds of glowing gases called nebulae that would later prove to be the birthplaces of stars. Many of them located along the Milky Way, like gems on a cosmic necklace. But even as the telescope uncovered the hidden treasures nestled within the Milky Way, it left a big question unanswered. Why is the Milky Way confined to a narrow band that wraps around the sky? It would take another century and a half after Galileo before someone had the beginnings of an answer. In 1785, William Herschel, a German-born musician and astronomer working in England, was already famous for his discovery of Uranus. It was the first planet in the solar system to be spotted with a telescope. Now Herschel was ready to turn his attention to the placement of the stars around the sky, including the Milky Way. His strategy was straightforward but painstaking. Pointing his telescope at over 600 different locations, Herschel proceeded to count all the stars he saw in each region, and he estimated the relative brightness of each star. Herschel guessed that fainter stars were further away than brighter stars. So when he put it all together, he came up with a picture of the universe that looked like this. It shows that we are embedded in a vast system of stars that has a flattened shape, like a giant millstone or a disk. In some directions, the stars are relatively few in number, but along the midplane of the disk, the stars become more numerous, their light adding up to form the glowing band of the Milky Way. Herschel's map was a huge step forward, but it was also just the tip of the cosmic iceberg. For beyond the limits of Herschel's telescope, a far grander Milky Way was still waiting to be discovered. By building on the work of William Herschel, astronomers in the 19th century had verified that our solar system is located within a galaxy of stars, shaped like a giant disk. This explains why the Milky Way appears to us as a glowing band of light stretching across the sky. When we look along the band, we're looking into the disk. But astronomers were not entirely satisfied with this early picture of our galaxy. For one thing, it meant the solar system had to be located near the center of the Milky Way, an unlikely coincidence. And without a way to measure the true distances to the stars, there was no way of knowing how accurate this picture of the galaxy might be. To get a deeper understanding of the Milky Way, astronomers needed new tools and new ideas. By 1912, they had both. The new idea was a way to directly measure distance in deep space, and its discovery was entirely unexpected. In the era before electronics, Henrietta Leavitt was one of several women employed by the Harvard College Observatory to do mathematical calculations. At that time, large amounts of data were flooding into the observatory, thanks to the development of astronomical photography. The female computers who worked at Harvard were not expected to make scientific discoveries of their own. But that is precisely what happened when Leavitt noticed a pattern in a certain type of variable star called a Cepheid variable. Leavitt saw that each Cepheid pulsed with a regular cycle, and that the length of the cycle was related to the total amount of light coming from the star. Simply by timing the pulsations of a Cepheid variable, astronomers could now calculate the star's true brightness, and then work out its distance by comparing that to how bright it appeared in the sky. The method was quickly put to use with the help of astronomy's most powerful telescope of the time, the 60-inch reflector high atop Mount Wilson near Los Angeles. Backed by the telescope's unprecedented power, Harlow Shapley, a crime reporter turned professional astronomer, would make galactic history. Shapley used the giant scope to examine globular clusters, distant concentrations of stars with a distinctly spherical shape. Each globular cluster contained hundreds of thousands or even millions of stars, circling around one another like bees in a swarm. Shapley believed that these clusters, in turn, must circle around the gravitational center of the Milky Way. By using Cepheid variables to measure the distances to the clusters, Shapley was able to work out the location of a point in space around which all the clusters appeared to be concentrated. The result changed everything. It showed that the real center of the Milky Way is located tens of thousands of light years away from us, in the direction of the constellation Sagittarius. For astronomers, the revelation was a cosmic wake-up call. Centuries earlier, it was Nicholas Copernicus who had nudged Earth out of the center of the solar system and put the sun there instead. Now it was Shapley's turn to push the solar system away from the center of the Milky Way. Shapley's discovery relegated us to the suburbs of a galaxy that is much larger than anyone had previously imagined. Today, astronomers estimate the Milky Way is more than 100,000 light years across. Yet even in Shapley's time, there was growing evidence that this vastly expanded Milky Way was only a small piece of a far grander cosmic reality. That evidence came in the form of a class of faint, fuzzy objects scattered around the sky that were coming into focus as telescopes improved. Many looked like little spindles. Others had a distinctly spiral shape. To some, it seemed that these faint swirls must be newborn solar systems forming within the Milky Way. But there was also a more radical possibility. Could they instead be other galaxies, like the Milky Way, but located far off in the cosmic distance? In the early 1920s, astronomer Edwin Hubble was able to prove that the answer was yes. Using the newly built 100-inch telescope at Mount Wilson, Hubble zoomed in on the largest of the mysterious spirals, the Great Nebula in Andromeda. There, he spotted Cepheid variables, the pulsating stars that would again prove crucial. This time, they allowed Hubble to calculate the true distance to Andromeda. The results would become a turning point in our understanding of the cosmos. Hubble's measurement showed that Andromeda must be a separate galaxy, far beyond the borders of the Milky Way. Today, astronomers have pegged its distance at more than 2 million light years away. Other galaxies are millions, even billions of light years farther. Hubble had discovered the rest of the universe. But he had also given astronomers a new way to think about the Milky Way by comparing it to other galaxies. The era of galactic exploration was about to begin. By the mid-1920s, astronomers had realized that the universe is full of galaxies. Like islands in a cosmic sea, the galaxies are separate systems, each containing hundreds of billions of stars. But this revelation raised many new questions about our own galaxy, the Milky Way. Was it a spiral system, like some of the others, that could be seen from afar? And if so, how would we know? It had taken centuries for astronomers to figure out that the Milky Way is shaped like a large disk, with the solar system located about 2/3 of the way from the center. Now the challenge was to map the Milky Way from the inside. This was no easy feat, and a big part of the problem is dust. Even ancient astronomers could see the Milky Way does not have a uniform appearance across the sky. Instead, it looks patchy and uneven, In some places, it seems split by dark rifts. This is because the Milky Way is interwoven with vast clouds of interstellar dust that block much of the galaxy from our view. Yet despite this visual barrier, there are clues that helped astronomers discern our galaxy's true shape. Among the first to follow those clues was American astronomer William Morgan. In 1951, Morgan was working at the Yerkes Observatory northwest of Chicago, where he was studying blue supergiant stars, the hottest, brightest stars in the galaxy. One night, while looking in the direction of the constellation Perseus, Morgan realized that a number of the giant stars he had been studying in that part of the sky were all located at about the same distance, between 5,000 and 8,000 light-years away. And so too is the Perseus double star cluster, a well-known feature in the same part of the sky. Morgan realized that the double cluster and the giant stars together traced a line through space, as though marking a structure embedded within the Milky Way. He had discovered the Perseus arm, one of the great spiral arms of our galaxy. Before long, other familiar sites scattered along the Milky Way were also shown to be part of the Perseus arm. Among them is the spectacular Crab Nebula, the remnant of a supernova explosion that was recorded in 1054. But if there was one spiral arm, there should also be others. By looking in the opposite direction from Perseus, astronomers found they could see traces of another arm that is located closer to the center of the galaxy. This is the Sagittarius arm, home to a dazzling array of star clusters and nebulae that adorn the southern Milky Way. Spectacular sights, like the Trifid Nebula, make this part of the sky a visual paradise. Closer to home, astronomers have determined that our own solar system is part of the Orion Arm, a smaller structure that may be no more than a spur branching off of Sagittarius. Yet the Orion Arm, too, is loaded with amazing sights, which loom large in our view because they are relatively close by. It is when we look down the length of the Orion Arm that we see the nearest, and to us, the most spectacular star-forming region in the sky. The Great Nebula in Orion, where thousands of new stars are being born before our eyes. Aided by radio telescopes and infrared satellites that can see through the galaxy's obscuring dust, astronomers have now peered deeply into the Milky Way to map its structure in detail. They have detected more arms and also confirmed that the Milky Way is not just a spiral galaxy, but a barred spiral. Barred spiral galaxies are common in the universe. Their elegant appearance is the product of an evolutionary process that causes material within the galaxy to form a horizontal bar running across the center. Now, more than 60 years after Morgan's initial discovery of the Perseus arm, astronomers can show us what the Milky Way might look like if we could view it from the outside. This is the result. An artist's view that shows our galaxy as a barred spiral with two prominent arms. One of them is the Perseus arm, the first to be mapped. On the opposite side is the Scutum Centaurus arm. It's much harder to make out from Earth, but astronomers have found that it hosts massive clusters of hot young stars, like this one, imaged in infrared light by the Spitzer Space Telescope. Completing the view are the lesser spiral arms that wind their way between the two larger ones, including the arm where our own solar system is located, right here. This is a view that no telescope can show us, but one that is supported by years of observation across the entire Milky Way. The mapping of our galaxy is one of astronomy's great achievements, but it's more than just a map. It's a snapshot of a dynamic star system with a history that has unfolded over billions of years, a history that relates directly to our own existence. In that sense, the spiral may be the ultimate cosmic symbol of life, for it's in spiral galaxies that new stars and new planets are born. It's the same process that led to our own solar system's creation in the Milky Way. In that sense, the spiral may be the ultimate cosmic symbol of life. For it's in spiral galaxies that new stars and new planets are born. And sometimes civilizations like ours, with a desire to map and to explore the universe around them.